Determine the equation of the circle with center 3 minus 2 and which passes through the point 6 and 2. Now always for coordinate geometry, always try and draw a little sketch for yourself. It makes it a lot more easier to see what you're going to use then. Alright, so let's see if we can do a little sketch for this question. Y-axis, x-axis over there, and the question says determine the equation of the circle with center 3 and minus 2. So on the x-axis you are actually on 3, which is about there, and minus 2 is around there. So let's say, for example, the point of the center is approximately there. Okay, so if we do a circle now around this point here, it's going to look something like that, right? But you also have a point somewhere on the circle, and that's at the point where x is 6 and y is 2. Okay, so let's say about around there, the coordinate 6 and 2 will lie over there. Okay. Right. Let's see if we can first of all determine the radius for the circle. Okay. Now where's my radius? It must be this length over here. That's my radius. Okay, and to work out your radius, we say according to Pythagoras, r square is equal to x square plus y square. Why do I use Pythagoras? Because I do have a coordinate. I do have an x and I do have a y. Okay? So write down this equation for me of Pythagoras. R squared is equal to x squared plus y squared. Okay, I'm going to call this point over here point P. So just put a P over there for me. So we can say r squared is actually CP square. Isn't CP your radius? Let's make it a C over here. Yeah. So we can say C is over here at coordinate 3 and minus 2. That's coordinate 3 and minus 2. Okay, so r squared is equal to CP squared. And then we can say it's going to be what? How do we work out x? Do you know that x is actually x2 minus x1? So you can call this, for example, x1 over here, y1, x2, and y2. So if you want to work out your x for your Pythagoras over here, you're going to say, it's x2 minus x1 on my sketch. So it's going to be 6 minus 3 in brackets square. If you want to work out the y, you're going to say 2 minus 2 in brackets square. So we have 3 square over here, and we have 4 square over there. So it's 9 plus 16, that will give me 25. Okay, 25. So we have r squared is equal to 25. Okay, if your point moves around, you can't just use r squared is equal to x squared plus y squared. You need to say x2 minus x1 squared plus y2 minus y1 squared. Okay. But when our circle moves from the origin 0, 0, it floats around, there's a formula to use. And what's that formula? Let's see. X minus a square plus y minus b in brackets square is equal to r square. So you use this formula when you're not on the origin 0, 0. As soon as your circle starts to float around, that's the formula to use. Right, now why do we substitute into A and into B? It's always going to be your center coordinates. And the center coordinates are this on my graph, on my sketch, this 3 and minus 2. So let's substitute in. So we say it's going to be x minus 3 in brackets square plus y minus 2, be careful, square. We already worked out r square. It's 25. Let me simplify a bit. Y plus 4, because negative times negative is positive. So just a correction, I just want to go back a positive 2, my apologies, positive 2 square is equal to 25. Okay, so we have x minus 3 in brackets square plus y plus 2 square is equal to 25. And there's the equation for the circle.